again. Here's the second part of question 6. I got this first equation up here that came from part A. Now, state dA over dx giving units. So dA over dx means find the derivative of or differentiate this equation, which goes like this. So we have dA over dx, and we differentiate that. The 2 comes to the front, we get negative 2 times that lot, so we get negative 6x to the power 1 less, and 81x, the same thing, and you end up with 81. And if you're not comfortable doing differentiating, use your calculator as a differentiating button. You can get it to do it for you. Now, the units. Okay, well, an area is measured in square meters, because this is doing paddocks, it's measured in meters, and x is a length, so that's measured in meters. So our units are meters squared for the area. So units for this, when you find a derivative, you're finding a gradient, you're finding a rate of change, you're finding something per something. So it's meters squared per meter, or you might write meters squared per meter, something like that. But it's area per length, meters squared per meter. Right, now let's find the part C. Using calculus techniques, determine the side length x. We've got to find what x is. That gives us the maximum total area. Okay. This equation that we have here for the area, minus 3x squared plus 81x, because it's got a minus in front of the x squared term, means we've got a negative shape, a negative quadratic that look like that. We'll be finding the maximum there. And the thing about maximums and minimums when you're doing minimum questions is that the gradient of your curve at the maximum is 0. The gradient at that top point is 0. And we use that piece of information to solve this. So, but we have to write that down first. So we have at the maximum dA over dx, which is our derivative, which is our gradient, that is equal to 0. Then we have, so therefore 0 equals, now I've already done the differentiating here, so I know what dA by dx is. It's negative 6x plus 81. And I just have to solve that to find what x is. Now, again, you could use a calculator, solve. So on your calculator, what you'll be doing calculator. Just use that solve button. And it'll just do the calculation for you, pump it out. I'll do it without. If you get an equation like this, you would add 6x to both sides, and you get 6x equals 81. And then you'll divide both sides by 6, and we get x equals 81 over 6. And that's just a division. We have to divide 6 into 81. So that 6 into 8 goes once, remainder 2. 6 into 21, 6 3s are 18, remainder 3, and 3 out of 6 is a half. So it's 13.5. And let's just check up. We better give some units here. They were fussy about that in the first part. Let's do it again. 13.5 meters. And let's just make sure we've answered the question. Using calculus techniques. Well, that is using calculus techniques because we needed to know that the gradient was 0. So we've done that. Determine the side length, and we've got what x is. That's it. Usually in these questions, it's not written here, you would, once you've found the side length, they actually ask you to find what the maximum area was. And if they had done, they didn't in this question, but if they had done, you'd take that 13.5 and you would have to substitute it into your area equation at the top here. So wherever x is, you'd put the 13.5 and work out what it came to. But in this question, no, that's all we need to do, and we can stop there.